Hi everyone, I'm Chelsea. This is a video for the class Ed 437, Science and the Young Child for SOU. So I was hoping you guys would do an experiment with me today. What I'm thinking about is water. What do you think about water? Do you have any thoughts? I think water is really interesting, and I like to kind of play with how it acts. So if you want to do some of these experiments with me at home today, all you have to do is get a few little things that you can find around your house. First, you'll need a glass full of water. Any kind of glass will work. Maybe a couple different kinds of containers that you can experiment with. Because when we're scientists, something we like to do is always try different things. They're called variables. And that's how we kind of figure out what affects something, what makes it do what it does. So get a couple different things to play with, different sizes, different shapes, different colors even. A couple other things you're going to need for our experiment today is something that does a dripper. I'm going to use a turkey baster and drip water with that. And you're also going to need some pepper. And you're also going to want some dish soap. Now, one other thing you might want to grab, if you want, this one's optional, you could get a few little things from outside, like a leaf, a piece of grass, a little twig I found, piece of little stick, a couple things like that. Oh, and one last thing, a Q-tip. So pause the video, get all those things, and then we'll do an experiment. Ready? Okay, so the first thing that I want to play with is how strong is water? You know, I was doing some research and I read that water has skin. Skin, just like you and me, skin. And I was wondering, how could we look at the skin of water? How could we see how strong that skin is? What do you think? How strong do you think it is? Do you think it could hold that grass, that leaf? Do you think it could hold a real stick, a big one? Do you think it could hold an elephant? What do you think? So let's write down some of our observations. That's what good scientists do. Get your pen and paper at home and maybe write down some of your ideas. Draw me a picture of the skin of water. What would that look like? I have a way here that I'd like to show you. So let's turn on over here towards my glass, my little experiment station. Here we go. All right, so this is just a glass of water. It's cold water. And what I'm going to do is use my squirter here to add some more water and see if we can get to see the surface of it. Here we go. Okay, so I know it's a little hard to see in the camera, but if you just kind of keep your eyes focused right in here, you'll kind of start to see the surface of this water, its skin, rise up above the glass. Now, one thing you could do at home is if you're experimenting with different sizes of containers for your water, is you could see how many drips it takes to fill up that glass and how many drips you can fit before it overflows. Now, I'm starting to see the skin of this water come right up above the rim of my glass. I can actually see that the glass stops and the water keeps going. And I can't believe water is still dripping. Check it out, guys. More water, drip by drip. Each time it takes that drip and absorbs it in and it clings to itself. Water is so clingy. And it's still holding tight. No water around my glass here on the table, as you can see. How long do you think it's going to go? How many more drips? 5 more drips, maybe? 1, 2, 3, 4, 5. Still none. Write down a number. How many more drips do you think it's going to take at this point? I'm going to say 5 wasn't enough. Maybe another 5. 1, 2, 3, 4, 5. Ooh, those were quick drips. Nope, still not overflowing. 1, 2, 3, 4, 5. Still, that skin is holding tight. You can see it all the way above the surface of the glass. It's really poking up. It's almost a little dome. Ooh, it's getting tall. Couple more drips and I bet it's going to overflow soon. Still, no overflowing. Anywhere you look around the glass, no moisture. Can you believe it? Wow. I thought this was going to happen a lot sooner. goes. That was a long time that the skin was able to hold tight. How many did you think it was going to take? Because I thought it would happen a lot sooner. Well, now we've got all this water here. I was wondering if there's other ways that we can figure out how the surface of how the surface of water is strong. So I have another container of water here I'm going to pull out for you to see. And I'm going to see if I can float some things on it. Remember that leaf and grass? Pull those out too. Okay, here's our big dish of water. There we are. And let's see if the surface is strong enough to hold up this leaf. Now, I know it's not very heavy. Something else you can try. If you have a paper clip at home, see if you can float it on the water. There's some great videos on YouTube out there if you want to see how it's done. I don't happen to have a paper clip, so I'm not going to do that one today. But there's some grass. Here's our little stick. And they all float right there on the surface. Now I know something else that floats on the surface, and it's pepper. Pull out your pepper, and we're going to do a little experiment here that shows us the surface of the water. Now I know that the pepper is going to float on the top, so I'm going to sprinkle the surface of my water here with some pepper. You should be able to see that on the screen, yep. So we're going to give it a pretty good coating here. I like pepper. I don't know about you. Maybe it's a little spicy for you. Ooh, I can smell it. It's going to make me sneeze. All right, so we have the top of this water is covered with pepper. A little bit has sunk down to the bottom, but most of it really stays right there on the top. That shows us how the water's surface is holding it. But I know something about soap. Soap, dish soap, is made to break water apart. It makes it so it doesn't cling to itself. So we're going to use this soap today to show us how that water does kind of run apart from itself. I have some soap here. I'm just going to put a little dab, and I'm going to use my leaf as a container. You could use anything you want. You probably don't even have to squirt it out. Then I grab my Q-tip, and I'm going to put a little tiny bit of soap there on the tip of my Q-tip. It doesn't take very much at all, as you can see. Now what we're going to do is put the Q-tip with the dish soap straight into the water with the pepper on top, and you can watch the surface move away from the soap because water clings to everything but soap. It does not like it. Watch closely. Here we go. There it goes. You see this spot right here? It cleared out. I'll put my soap in again right here. It gets away from that soap as fast as it can because soap breaks apart the way that water clings. Now at home you could be doing this too, and you can play with it for quite a while. At some point your soap will take over your water so much that you won't be able to do it anymore, but you can kind of play with it for a while and see if maybe more soap makes it move quicker. Does less soap make it move less? Does it matter how much pepper you have? Ooh, fresh soap, that one made it really move. There's so many variables, many things you can check out and see exactly how it reacts. So those are just a few experiments you can do on water. Back to me, here we go. And there's other things you could play with too to see how it reacts. Maybe I was wondering if the heat of the water, was hot water and cold water, do they act the same? Is the surface as strong? Does it matter if you have a big container or a small container? Maybe if there's only a little space it has to hold on to, it's easier than a big space. That's my guess, but I don't know. There's a lot of things you could check out and see how the surface of that water acts. So thanks for joining me in my experiment today. I hope you had fun learning about the way that water works, and I'll see you next time. Thanks.